Most Colorado State University students, faculty and staff, and other visitors are unaware that campus displays a green roof. During the Microbiology building's renovation in 2008, a 400 square foot experimental green roof was designed, installed, and continues this very day. The green roof top began as a collaboration between CSU's professor of horticulture Jim Klett and PhD student Jennifer Bousselot. The pair sought to research the effectiveness of plant species, growing mediums, and rooftop systems, doing so under a grant with the Environmental Protection Agency. Green roofs, or living roofs, are practiced all over the world. Seemingly, the United States is struggling to catch up with more progressive technologies and best practices. For example, the ASLA green roof demonstration. Living roofs produce many benefits, including the ability to moderate temperature on or near an installed building, contribute to cooling cities during hot summer months, lessening the heat island effect, to capture pollutants and filter noxious gases through biological evapotranspiration, like vertical urban greening for pollution mitigation, to filter water runoff and delay runoff time, which may ease loads to a sewer system during peak flows, and lastly, to store water in soil substrate for later usage by plant life. Socially, green roofs offer opportunities to educate students and others in the public view about biology and architectural and engineering technologies. Living roofs have been known to be used as community gardens, recreational space, inspiration points, wildlife habitat, and are an easy method for beautifying a built environment.
The construction process began by installing an extra EPDM membrane and adequate roof drains to prevent ponding. This was accomplished so that the original roofing company would warranty the roof system after the living roof was installed. Testing of the roof drains and the additional membrane was accomplished prior to install. After successful testing of the improved roofing system, planting trays were installed and cultivated. Later on, a watering system had to be installed in order to keep the plant life alive and thriving during the dry season. A higher static load on the roof required reinforcing the building's structure, as opposed to being built to a stronger criteria initially. An additional waterproof membrane was installed in order to keep the water out of the building. Proper drainage systems had to be installed for rainwater and irrigation. The irrigation system keeps plants from drying out, deteriorating, and loosening and depleting the soil. Some challenges were getting the roof drains sealed correctly. They leaked at first. 3 initial tests showed that the roof drains and scuppers weren't sealed correctly. Thus, water leaked into the downstairs repeated times. Isolating the proper type of plants onto the living roof and getting the existing plant material to survive without watering was impossible. An irrigation system later had to be installed.
Plant life and soil dependency are critical and interdependent. Because of dried out soil, the plant life has been plugged a couple of times. New plant life has been installed and the lot fertilized. Soil integrity is critically dependent upon the successful life of the plants. Irrigated moisture content has been critical as well to keeping a densely weighted soil medium suitable for retention against wind scour. In addition to keeping the original sedum plants alive, additional wildflower and other native plants have been installed for coverage. The living roof is weeded and trimmed annually, thus protecting the rooftop edges and systems from harm. Some unforeseen benefits is that the living roof attracts more visitors than was originally anticipated. A wide variety of research and lessons learned for what not to do on a living roof have been accomplished. Draining methods and roofing systems have been improved through experimentation, and more or less the roof can now self-sustain.